Hi folks, you're all very welcome to this geotopic session on geothermal energy and potential in Northern Ireland. My name is Rory Quinn and I'm a geologist based here at the School of Geography and Environmental Sciences at Ulster University. So first things first, what is geothermal energy? Well, geothermal energy is all the energy stored in the form of heat beneath the surface of the solid earth. And it's derived from the decay of the radioactive elements in the Earth's crust and transferred to the subsurface by conduction and convection. And importantly for society, it is a reliable and a constant source of low carbon renewable heat that is not dependent on weather conditions. So the renewables that we're probably more used to in Northern Ireland, including wind and solar, are very much dependent upon the vagaries of weather conditions at any given time. For us, and as a society, it's really important that geothermal is a constant source of low carbon renewable heat that is not dependent on these weather conditions. So if we look at the thermal structure of planet Earth, so planet Earth is about 4.6 billion years old. At the centre of Earth, about 6,000 kilometres beneath the surface, we've got temperatures about 5,500 degrees centigrade. And incidentally, these are very similar temperatures to the surface of the sun. So that's how hot planet Earth is at its centre. And then as we move closer to the surface, these temperatures decrease. Okay? But even at depths of, say, 1,000 kilometres beneath the Earth's surface, we've got temperatures of 1,700 degrees centigrade. And this heat is derived from the original formation of the planet and from the decay of the radioactive elements in the Earth's crust, and is transferred to the subsurface by conduction and convection. And we can exploit geothermal energy in two different senses: shallow geothermal and deep geothermal. So what is shallow geothermal? Well, shallow geothermal tends to be supplemented by ground source heat pumps, and as the name suggests, it tends to be geothermal energy which has been exploited shallowly within the Earth's crust. So typically within the top sort of couple of 100 metres of the Earth. And these systems are supplemented by ground source heat pumps. So for example, if we've got a house at the surface of the Earth and we pump cold water down through a closed loop system at a depth of 30, 40, 50 metres, okay, the ambient temperatures here beneath the surface are about 10 to 17 degrees centigrade. So that means our cold water is heated to these temperatures, and then we can pump this warm water back towards the surface, boost the temperatures with our ground source heat pump, and then heat our house in this way. And of course, we can do this not just for individual buildings, but we can use shared ground loop arrays to heat groups of buildings together. Okay? And another shallow example that we can use is we can use disused mine workings. So typically these mine workings might be at sort of depths of couple of 100 metres right down to about sort of 700-800 metres beneath the surface of the Earth. And at these depths, temperatures are about 25 degrees centigrade. So again, if we pump cold water down in a closed loop system down to these depths and circulate it there, it will then be heated to 25 degrees centigrade, and we can pump this warmer water back towards the surface and then supplement it using ground source heat pumps to heat arrays of buildings. So that's shallow geothermal. And what's deep geothermal? Well, as its name suggests, this is using geothermal heat from deeper within the Earth's crust. So typically at depths of 1 kilometre to about 5 kilometres beneath the Earth's crust. So here we drill directly into the Earth's crust and we're just extracting water at very high temperatures. So typically between about sort of 60 to 100 degrees centigrade at a kilometre's depth. At a couple of kilometres depth, then we can use things like depleted hydrocarbon reservoirs. And if we go deeper again into basal granites, we can extract water at temperatures of about 180, 190 degrees centigrade, and we can heat whole cities in this way. So that's the main difference between shallow geothermal and deep geothermal. Well, what about its use on a worldwide scale and its potential within Europe? So on a worldwide scale, here's a graphic from 2015 showing global geothermal use. The dark greens here show where it's exploited for heat and electricity, the light green for heat only, and the blue for electricity only. And you can see large tracts of Europe, China, Australia, United States, Canada, South America, etc. are exploiting geothermal energy already. And if we zoom in on Europe, and this is a colour-coded map again, which shows geothermal heat at 2,000 metres depth beneath the surface. And these values are in degrees centigrade. So the very dark reds are temperatures in excess of 200 degrees centigrade, right up to the yellows, where we've got temperatures of about 40 to 60 degrees. So you can see large parts of Hungary, Germany, Central Europe, the Netherlands, France, Italy, etc. Have huge potential in terms of geothermal energy and indeed are exploiting this as we speak. Okay. In Ireland then, especially in the northeast of Ireland, we've got good potential shown up on this map for geothermal resources. So let's look at a couple of case studies now. The first case study is the Munich District Energy Scheme, and they aim to have carbon dioxide neutral heating by 2040, primarily with geothermal, with an investment volume of around 9.5 billion euros. Okay, so this is Germany's largest geothermal plant with 6 boreholes at about 3,000 meters depth and has been in trial operation since 2021. And the total plant currently has a thermal output of 50 megawatts, and in full operation this plant produces enough heat to supply 80,000 residents in an environmentally friendly way. And by the year 2040, they hope to have the whole of the Munich area heated in this sense. Closer to home then, we've got a case study from Southampton, which is on the south coast of England. And the Southampton District Energy Scheme has been up and running since 1986, and it's using water from the Wessex Basin Aquifer, which is at a depth of about 1,800 metres and has a temperature of 76 degrees centigrade. And this system supplies many buildings within Southampton, including 1,000 residential properties, the Civic Centre there, the West Quay Shopping Centre, the Royal St Hans Hospital, Solent University and the Carnival offices. By 2007, the system had 11 kilometres of pipes, was producing 40 gigawatt hours of heat, 22 gigawatt hours of electricity and 8 gigawatt hours of cooling per year. And there's a brilliant graphic here showing that the Southampton District Energy Scheme has saved 119,000 tonnes of carbon dioxide since its operation began in 1986. Okay, so that's an example of a scheme very close to home for us. So then, what about the geothermal energy and the case for Northern Ireland? Well, luckily for us, there's very favourable geology in Northern Ireland with huge untapped potential for geothermal energy. And recently, two of the state agencies have set up the GeoEnergy Northern Ireland project, which aims to prove the potential of geothermal energy within this region. There's a brilliant website, and the hyperlink is here, that you can have a look at. There's really lovely graphics and really good explanations of the potential for geothermal energy in Northern Ireland on that website. So what makes this achievable for us? Well, it's the Sherwood sandstone, and this is an aquifer which is really good porosity and really good permeability, and it actually underlies most of the northeast of Northern Ireland, extending from Belfast and Portadown in the south right up to the north coast. And we've got temperatures here of 100 degrees centigrade, 2,000 to 2,500 metres beneath the surface, right up to ambient temperatures in these greys here close to the surface. So this aquifer underlies Belfast and other towns and cities across a large part of Northern Ireland. And because it occurs at a range of depths, the water within the aquifer could provide geothermal energy for a range of heating and cooling needs. So we can therefore exploit shallow and deep geothermal from this aquifer. The main opportunities for utilising this energy source within Northern Ireland lie in its heating applications. And the GeoEnergy NI demonstrator project, which was set up a couple of years ago, is focusing on 2 key locations. So one is the Caffrey Greenmount campus here, just south of Antrim, and this is exploiting its proximity to these very hot fluids at about 2,000 metres depth. And then the second demonstrator site is at Stormont, east of Belfast, and this is exploiting the aquifer, which is actually very close to the surface, which is ambient temperature about 15 degrees centigrade. So the Greenmount campus was chosen because it is above deeply buried porous sandstones that contain naturally occurring hot water at about 70 degrees centigrade at depths of about 2 to 3 kilometres. And this deep aquifer presents an opportunity to explore the future development of a geothermal district heating network and an opportunity to decarbonise horticulture or other agri-food processes. So, give you an example of that. Some of the most beautiful tomatoes I ever tasted were in Iceland, and they were grown in these massive polytunnels which are being heated effectively by geothermal energy. So there's potential in Northern Ireland to decarbonise a lot of its horticulture by exploiting this deep geothermal energy. And then the second demonstrator site is at Stormont, and the Stormont study will focus on shallow geothermal to provide heating and cooling for buildings on the Stormont estate. And the Stormont site is underlain by a near-surface aquifer containing groundwater about 15 degrees centigrade. And this shallow system will require ground source heat pumps to increase the low temperature obtained from the geothermal resource for use in domestic or commercial heating applications. So I suppose the good news there, folks, for us is that all of these possibilities are apparent for Northern Ireland because our geology lends itself to this. And if you're interested in looking into this more, there's some fantastic resources online. So, for example, the GeoEnergy Northern Ireland site that I've alluded to already, the hyperlink is here. And this is run by the Department for the Economy together with the Geological Survey of Northern Ireland. The Geological Survey of Ireland have a fantastic site also on geothermal energy with the hyperlink here. The BGS, the British Geological Survey, has a fantastic site also with lovely graphics actually here called What is Geothermal Energy? And then perhaps best of all is the ARENA site, the International Renewable Energy Association site on geothermal energy, which has the hyperlink associated here. So folks, thank you very much for listening today, and I hope you have a good day today looking at the renewable possibilities in Northern Ireland.